A few months ago I turned testosterone into femboy powder, and today I will be following the trends and turn estrogen into Trenbolone so I can finally get big and strong. So, what is Trenbolone? In short, Trenbolone will lead to gains of massive amounts of muscle mass in a short period of time. But of course, this comes with its downsides, which is why many countries like the USA have made it illegal. But fortunately I am in Germany, which makes it less illegal. Why would anyone want to make Trenbolone? I like the challenge of turning something feminine into something masculine. And I'm kinda crazy, so why not? Come on, do something. Oh, it looks like biochemistry ain't gonna cut it today, and I will have to put in actual work. I ended up doing research for 4 hours, and in the end I stumbled upon 2 very promising papers. Hell yeah! These papers contain exactly what I was looking for, and in comparison to biochemistry, it's not even black magic. Today's preparation is probably going to be easy, and I'm also sure that it's not going to require many chemicals at all. In the first step, I will make methyl iodide, and these are the required chemicals. I weighed out 30 grams of this red powder, which the DEA doesn't like. This is a small excess. I also need methanol, and as I am too lazy to clean even more glassware, I weighed it out in a red phosphorus beaker. Lastly, I need 253.8 grams of elemental iodine. Iodine makes a beautiful purple and deadly cloud when you heat it up. Before beginning with the actual chemistry, I have to warn you though. Methyl iodide is not exactly what I would call healthy. So what is so bad about methyl iodide? It is going to give you cancer, and you are going to die a very slow and painful death. As the reaction generates heat, I added the iodine in portions with stirring and stopping in between. 2 reactions are taking place here. In the first step of the reaction, iodine and phosphorus react to form the chunky molecule phosphorus triiodide, and in the second step, this reacts with methanol to form methyl iodide. After the last addition, I let it stir overnight, and the next day I distilled off the product using a simple distillation. Not gonna lie, but it looks like someone has been murdered inside this flask. About 10 minutes after I started heating, the first drops of liquid cancer started coming over. In the end, I was left with this. It contains 2 layers because of excess methanol. To eliminate the iodine and get rid of the excess methanol, I made an aqueous sodium thiosulfate solution. While methyl iodide is insoluble, iodine gets reduced and methanol dissolves in the water. A tiny amount of water, however, will stay behind in methyl iodide, making it cloudy. I'm going to try removing that water using anhydrous calcium chloride. It worked, and the methyl iodide is now pure and clean. I put it into 2 containers and weighed them. I got 256 grams of product, which is a 90% yield. Even 8 grams of unreacted red phosphorus were recovered. Methyl iodide is commonly stored over a piece of copper or even over a drop of mercury. You can also see the interesting refractive properties here. For the second part of the synthesis, I am finally going to use estradiol, which is a female sex hormone. Make sure not to get any of the hormones into your body, because they can easily mess with your system. And of course, the girl powder had to make a massive cloud of dust, therefore I left the lab before inhaling any. As this is an etherification, we are going to need a base. I weighed out potassium carbonate and added it. The solvent of choice is acetonitrile. Like always, I am going to use small-scale equipment like this 6-liter heating mantle. From the liquid cancer, which I made previously, I am going to utilize 82 milliliters. Even if I don't show it on video, I take a lot of safety precautions because I absolutely hate working with carcinogens. Please don't repeat any of the stuff I do. It is dangerous. When it started boiling, I set a timer and refluxed for 16 hours. Here's the reaction taking place. Estradiol is turned into estradiol monomethyl ether. This reaction is known as the Williamson ether synthesis, and you only get the monomethyl ether because the hydrogen on the phenol is way more acidic than the other one. An alkoxide, which is crucial for this reaction, is more easily formed with a more acidic hydrogen. A millennia has passed and I stopped the heating and added a liter of distilled water. I got two cleanly separated layers, but to extract the product even more efficiently, I am going to add a liter of ethyl acetate in total. There's still acetonitrile in the aqueous layer, meaning a small amount of product is going to dissolve in it. With the ethyl acetate, this problem should be resolved and I'm going to get much more product. I drained off the aqueous layer without discarding it, put the organic layer into a different flask and extracted the aqueous layer again with ethyl acetate. To dry the organic layer, I shook with saturated sodium chloride solution and as the last step added molecular sieves. Using a simple distillation, I got rid of the solvent and this should leave us with the first pure intermediate towards making Trenbolone. If you are curious, I am not throwing the solvent away. I always use redistilled solvent for cleaning glassware. I evaporated off the rest of the solvent, scraped it together, and now I am left with estradiol monomethyl ether. To purify it, I recrystallized from the smallest amount of isopropanol possible. Once recrystallized, I filtered it off, dried it under a vacuum, and then weighed it. I got a 98% yield, which is 4% more than in the paper. As a German, I am likely a way superior chemist, but what is more likely is that my stuff still contains solvent and is thus impure. And now that this is done, there's only 6.5 more steps to go. In the next step of the synthesis, I will need to make anhydrous ammonia. In the USA, anhydrous ammonia has a bad reputation. Some people there who don't even know basic chemistry are using it to make meth. I am going to use it for legal purposes, but before we can even work with anhydrous ammonia, I have to make it, and I'm going to make it from urea. 600 grams of urea and 400 grams of sodium hydroxide were put into this flask. To get the reaction started, I added distilled water and after adding enough, also turned on the heating. I had to be very careful while doing this. Anhydrous ammonia is highly toxic when inhaled and it could easily kill me. I ended up with about 400 milliliters in this dry ice cooled flask. The product from before, which has this very easy to remember chemical name, was dissolved in 150 milliliters of dry isopropanol and THF. I slowly dripped it into the anhydrous ammonia and then added 22.5 grams of sodium. When sodium metal is thrown into anhydrous ammonia, we get this very interesting metallic color. We are looking at solvated electrons here. I let it stir overnight and the next day added 100 milliliters of methyl hydroxide to quench the unreacted sodium. I heated up the flask in a very well ventilated area to get rid of the liquid depth and the solvents. I added 700 milliliters of water, shook the flask and did a vacuum filtration. I dried it in a vacuum chamber over potassium hydroxide and didn't even weigh it. It will be used like this for the next step. Fortunately for today, there are no more highly toxic steps. This reaction is known as the Birch reduction. If you enjoy chemical mechanisms, you can have a look at the mechanism here. Usually, splitting ethers is not that easy, but because of the last step, I am dealing with an enol ether. Enol ethers are a very special kind of ether. They can easily be split using an acid. I dissolved my white powder in 350 milliliters of acetone. Later, I dissolved 19.3 grams of oxalic acid dihydrate in 135 milliliters of distilled water and added it. I stirred it at room temperature like this for 3 hours and then extracted 3 times using 125 ml of DCM each. Because of density issues, I saw this lava lamp-like effect. I would have preferred a clean phase separation, but it looked damn cool, so it was worth it. As it turns out, I should have added 100 ml of distilled water before doing the DCM extraction. Anyways, I added the water later, and this shouldn't have messed up anything. At least I hope so. The DCM was washed 3 times with 100 ml of saturated sodium bicarbonate solution. This step is going to get rid of leftover oxalic acid. Then it was washed 3 times with the same amount of water. Like in the previous step of this preparation, the DCM needs to be dried. Unlike the last time, instead of molecular sieves, I am going to use way less expensive anhydrous magnesium sulfate, which was made by heating hydrated magnesium sulfate on a hot plate. During the simple distillation to get rid of the solvent, I noticed that inverse bubbles formed. I've never seen something like this before. At some point, most of the solvent was gone, and I blew argon through it to dry it completely. The white powder looks pretty fluffy, and I got 19 grams of it. Fortunately for today, there are no more highly toxic steps. You know what? I lied to you and successfully deceived you. There's going to be one more highly toxic step involving bromine. I'm going to use the bromine to make a mild brominating agent called pyridinium tribromide. I added pyridine to the round bottom flask and then added hydrobromic acid to make pyridinium hydrobromide first. I added half a liter of water and then slowly dripped in bromine. The product is insoluble in water and immediately crashes out as a red powder. For whatever mysterious reason, it completely liquefied after all the bromine had been added. I fixed this by adding about 50 more milliliters of hydrobromic acid. Upon letting it stand overnight, it even grew these somewhat scary looking crystals. I filtered it, dried it over boiling water, and then let it stand in the desiccator of a potassium hydroxide for a week. Okay guys, this is the first step where we are going anabolic. But first, quick disclaimer. I don't want this video to promote steroid use. All of you know that steroids are bad for you. I would never take steroids myself and only produce this video as an educational experience. I also did very deep legal research because I don't want to do anything illegal. Like this testosterone, I could buy Trenbolone if it's for scientific and not for human use. I may have used normal pyridinium tribromides, but the paper used something very different. They used ponyvinyl pyridinium tribromide, which I don't have. But as the solvent is pyridine, this doesn't matter. The tribromide ion is free to move and the ponyvinyl thing shouldn't matter that much. I measured out 600 ml of bottled infertility. The brominating agent easily dissolves in the pyridine. Now I am going to go anabolic by adding the product from the previous step. I stirred the red angry looking liquid for 24 hours and then added 400 ml of dihydrogen monoxide. To neutralize the pyridine, I added 700 ml of hydrochloric acid. With small additions, I later made sure that the pH was about 2. I extracted the product 3 times with 200 ml of dichloromethane each. And because I'm lazy, I later on sucked the dichloromethane out of this flask with my ingenious vacuum invention. To purify the DCM layer, I made a saturated sodium bisulfate solution and washed it 3 times with 200 ml each. After that, I washed it 3 times with 200 ml of water, and like the last time, I'm going to dry with magnesium sulfate. I was contemplating to do a vacuum distillation, but then I remembered that dichloromethane had a boiling point of only 40 degrees Celsius and ended up doing a normal one. To get rid of the last few grams of DCM, I blew air through the flask overnight. I dissolved it in a minimal amount of hot isopropanol while having to stir manually because the stirrer broke. cooled it down, dumped out the isopropanol and dried the rest using the trusted pump method. I finally have a steroid, and now it's time to make it even more aggressive by turning it into Trenbolone, which is the worst steroid in existence. I dissolved 5 grams of dihydronandrolone in 15 ml DCM, 2.5 ml of methanol, and added 0.1 grams of p-toluene acid. Into a different flask I put 18 ml of methyl hydroxide, 5 ml of DCM and 3.1 grams of trimethyl orthoformate. I added the steroid solution over the course of 2 hours, and what was interesting is that after each addition the solution first turned blue and later on yellow again. I have absolutely no clue why this is happening, and I'm curious why. If you have an idea, please let me know down in the comments. 6 hours in, I added distilled water to destroy excess orthoformate and let it stir for 2 more hours. Then I added 0.25 grams of toluene sulfonic acid in 20 ml of water and let it stir for 6 more hours. In this reaction we get the dimethyl acetal in the first step and the double bonds are rearranged. In the second step, in the presence of water, the acetal is destroyed and we get back our ketone. There's only one step left to go until I have my favorite steroid, but before that I will have to get rid of acid impurities, and I did that by washing with sodium bicarbonate solution. In the paper they distilled off a lot of the DCM, added fresh DCM and distilled some off again to get rid of the water. I am not going to do that. I already inhaled enough DCM fumes for this year, and I am going to dry it using molecular sieves.
24 hours later.
I filtered off the sieves, washed them with more DCM and transferred everything to an addition funnel. To the man-powder solution I added 1.2 ml of glacial acetic acid.
It's finally time to Tren.
To make Trenbolone I am going to dehydrogenate using DDQ. I dissolved 4.8 grams of this angry looking sand in 35 ml of DCM. This reaction needs to be cooled, therefore everything needs to be put into an ice bath, and to make it extra cold, I added sodium chloride. I added the steroid solution to the Trenbolonizator 5000 and it should quickly be turned into Tren. I stirred for 2 more hours and I'm now going to quench the DDQ. For this I dissolved sodium disulfide in methanol and water. By the way, if excess DDQ reacts with water, it forms deadly hydrogen cyanide. I just wanted to put that out there. I filtered it off and washed the filter cake 2 times with 20 ml of DCM. I got rid of the water layer and I'm not going to bore you to death now by telling you exactly what I did. It's on screen. I put the washed solution into a big crystallizing dish and evaporated off most of the DCM on a hot plate set to 30 degrees Celsius. I redissolved the Tren in a minimal amount of boiling hot acetone and put the flask into the freezer. The next day something precipitated out and I got rid of the solvent. To dry it completely I need to get a good pump. Well, not that kind of pump. That kind of pump. There you go, this is Trenbolone. It's 96% pure and I got it tested by a friend who had access to various analytical equipment. I want to warn you one last time, do not use this on yourself. 96% purity means that there are nasty impurities in it, and these impurities are certainly going to mess you up. Unfortunately, I didn't get any worthwhile yield from evaporating the leftover acetone. Specifically for this video, I got this fancy packaging. For fun, I'm going to turn the other half of the Trenbolone I made into Trenbolone acetate. This should be really easy, as it is a simple esterification. I dissolved the Trenbolone in DCM, added p-toluene sulfonic acid, put everything into an ice bath, and then added acetic anhydride. The reaction taking place is called an esterification, and I directly get Trenbolone acetate. I let it stir overnight, and the next day it had this weird green color. To get rid of formed acetic acid and toluene sulfonic acid, I washed it one time with distilled water and one time with sodium bicarbonate. Unlike the last wash I did, it didn't foam as much and I didn't spill any. It's fun to turn around the funnel. At the beginning it looks nearly completely full, and when you turn it around, it looks near empty. I transferred it to a flask and dried it with the trusted air pump method. I tried to recrystallize from isopropanol, but it did not turn out well, and I evaporated off the isopropanol and instead recrystallized from MTBE. And that's it, Trenbolone acetate. Once dry, I got 1.3 grams of Trenbolone acetate. That's a yield of 80%. I put it into a fancy vial for my collection, closed it up, and it looks amazing.
And that, my friends, is how you make Tren. Don't abuse the sacred knowledge, and if you want to see more like this, make sure to subscribe.
I would like to thank all of my Patreons. I very much appreciate your support, and I can't thank you enough. If you want to support me and become a Patreon too, please feel free to check the link in the description.
Yeah, that's probably too much fog.